For the circuit shown, assume that the NMOS transistor is in saturation region. Its threshold voltage VTN is equal to 1 volt and its transconductance parameter mu Cox W by L is 1 milliampere per volt square. Neglect channel length modulation and body bias effects. Under these conditions, the drain current ID in milliamperes is dash. ID here is what is being asked. The first thing is we need to find what is VGS. VGS is here. The current that will be drawn by the gate will be 0, and we have R1 and R2 here, which can be taken as a voltage divider network. Hence we can find what is the value of VG here. VG will be equal to 5 mega ohms divided by 5 plus 3 mega ohms, which is 8 mega ohms, times VDD, which is 8 volts. So the result would be 5 volts. Now in order to find VGS, obviously VG, which is 5 volts, is equal to VGS plus the voltage drop across 1 kilo ohms. So the current flowing through it is ID. So the voltage across 1 kilo ohm will be ID times 1 kilo ohm. Now we are supposed to find what is ID. ID is equal to mu Cox W by L times VGS minus VTH whole square divided by 2. This is the drain current equation when the transistor is in saturation. We are already told to assume that the transistor is in saturation region. And the answer is to be given in milliamperes, which means ID is going to be in milliamperes. So let me consider that. So if ID is going to be in milliamperes, let's take the milliamperes out and multiply with kilo. So what we get is 5 volts is equal to VGS plus 1 milliampere times 1 kilo will be 1 volt, which means the value that we get will be, ID will be simply a number times volts. So now let's substitute this VGS value, which is VGS is equal to 5 minus ID. Let's substitute that in this current equation. So ID will be equal to mu Cox W by L is 1 milliampere per volt square. So we have to be careful here that ID we are assuming already in milliampere. So hence I cancel milliamperes on left side to right side, times VGS is 5 minus ID. 5 minus ID minus VTH is 1 whole square divided by 2. So we can write this 2ID is equal to 4 minus ID whole square. So 4 16 plus ID square minus 8ID. So we have ID square minus 10ID plus 16 is equal to 0. Now let's find what is ID. ID is equal to minus of minus 10 plus or minus square root of 100 minus 4AC, which is 64 divided by 2A. So this will be equal to 5 plus or minus square root of 100 minus 64 is 36. Square root of 36 divided by 2, this is 5 plus or minus 3. So we have a value of either 8 or 2. We know the units will be in milliamperes, that's what we have started with, and we'll have to see which one is correct. So we have an equation at the output side, that is at this side, VDD is equal to RD times ID plus VDS plus RS times ID. So this is 8 volts is equal to RD plus RS is 2 kilo ohms. 2 kilo ohms times ID plus VDS. Now if we take 8 milliamperes, obviously this itself will be 16 volts. So it doesn't make any sense, right? Then VDS should be negative. So hence this cannot be correct. So the right answer would be 2 milliamperes. So the answer is 2.